last video of the week here. Going to put you right in the driver's seat. We developed those two films, one automatic, one manual. Whoops, I just kicked you there. Sorry about that. Here's our automatic process. Okay, pretty good looking little film. We're just going to get right up in here and take a look. You see the little red light from my video camera there. You might be able to see it, you might not. We might have to go to the viewing light over there. Right above my finger is the 4T hole. Okay, right over here above my finger now it's a 2T hole. And that might be kind of hard to see. But we'll see that on the viewer here in just a minute. So now we actually want to take a density here. We're on the densitometer. You can see back there it says 0.96, now it's 0.01. We're going to null that out. Okay, this is how you'd operate this densitometer. You'd warm it up, let it come on. Okay, we null it out, then we hit this button here a couple times to make sure. Okay, then we take our density readings. So we're coming out about 1.7, 1.8, and I'm just taking a couple here throughout wherever, 2.8. This is important because we have to have a 1.8 density in the area of interest. Well, our weld is the area of interest. So in this case, just taking this shot, we have enough density there, but if there's any point on this weld that's less than 1.8, which you just saw right there, that means we don't have enough density to run this film out. So that actually means that we need to go back through and reshoot this and up our time just a little bit. Okay, we can use one of those ratios to do that with, but just for now we're just going to look at this and see what we could see from it. Okay, we're at 1.7 there again, we're not dark enough. Now if we were using this 2.8, 2.9, something like that, we'd be in great shape. Okay, we're going to look at this dark spot here, we're right at a 2.5. Ideally for our welds we want to be at that 2.5 range. So that means we were at a 1.7, we'd have to add about 30 seconds or so to it to get a nice clean density that we want. So we're just looking here. Just for now, we could go back and reshoot these. Here is our manual process. Easiest way to tell if it's a manual process, you see that hole right there in the side of the film or at the edge of the film. Okay? That is from our manual process hanger. Okay, one in each corner. There they are. So now you know that that's a manual process film. Okay, so we look here. Density again, 0.85. We better make sure it's zeroed out still. It is. So there's our 0.85. Okay, and we know here this guy's way too light. It's only 0.94. Okay, 1.5, and there's not one place on here that's dark enough to even run this out. So we know that right off the bat, we ran a manual process. It came out lighter because I ran these films together. These two films I processed together, took the X-ray together. I ran one through the automatic, then I ran this one through the manual. So that tells us that our manual processing chemicals are cooler, so we need to go back and run that longer, which we could probably get away with running high or dark on this automatic process and then getting light readings here. There'd be nothing wrong with that. We would just have to be aware that we need to have at least a 1.8 density here. And since we have a couple that are just under 1.8, we know that we'd have to go back and reshoot that. And I think it was right over here. Yep. So we're about 1.75, so we know right off the bat, okay, we've got to go back and reshoot that. So, just a simple way to read the density. Okay, this little black spot right there is where we're getting our light. Okay, you see the light back here, that's kind of a backlight. Down inside there, this is a logarithmic light reader. So what it's doing is telling us a ratio of the amount of light that's out here to the amount of light that gets through there. Okay, so we need at least a 1.8 density for X-ray, 2.0 density for gamma ray. So if we say, alright, we're good with that, if we turn around and come over here, which you're not turned yet, but you soon will be. Okay, if I just turn you around and come over here, there you see a little glow. We're going to bring you up like that. You're going to sit right up here next to me. I'm going to roll you up a little bit. There you are. Okay, now you're sitting right here next to me. We grab these films. We're just going to place them right up here next to each other. And there we go. If we had something to block the bottom of this with, which we'll have something right here. No, that's okay. We'll be fine without it. We can see just right off the bat, even though this is a light film, we see some discontinuities over here, which we'll get into this next week. there's another discontinuity. But what we're mainly focusing on here and here is our wire pinning. Okay, we see 1, 2, 3, 4, 5, 6 wires. There's only 6 wires in that pinning. So let's zoom in on that so you can see exactly what I'm talking about there. So if we were looking there, and you can count these wires, you see 1, 2, 3, 4, 5, 6. So here we're looking at just those 2 images. There's our auto image. There's our manual image. Okay, and again, here's a couple defects. You see the same defects over here on the auto process. And I put these here. This was for undercut. We really didn't have a lot of undercut here, but if you look just right over here on the edge, okay, let me roll you down a little bit. If you look right here on the edge, you see some fuzziness going on right here and over here, but right along the side there's nice and clean. Those edge blocks eat up that undercut and they clean up that image for us. So that's nice, and you can see it right there and right there, which is completely fine, and that's exactly what we want it to do. So we go from there now. This is a prime example of why we're way too light, because if we jump up here, try and zoom in a little bit on that penny, we can barely see the 4T and 2T. Now granted, we can see them, but they're not as good as they should be. So we go to our other film here, and we easily see the 4T and 2T. Now, you might not be able to see them right there, so I'm going to zoom you in again. And we're going to take a look right there at that 4T and 2T hole. There's a 4T on the right, okay, just above my finger right there. 2T's right over here on the left. Now, if we were actually going to view this, okay, you're back in the holster here. If we were actually going to view this, we'd come over here to this light box. And I'm going to hit the switch, and that's going to turn our light on over there. Okay, I might have blinded you there. So we're going to roll this up. I'm going to pull you back out of here again. That way now we're localized. Let it focus there a little bit. You should be able to see those 4T and 2T holes a lot easier. Okay, so there's our penny. Here is the wire penny. 1 ASTM-B right there. Okay, there's all our wires, and you can see those pretty simply. Okay, looking at a defect there on the left, right above the red light. And then we're looking right there at the defect kind of in the center of the screen. So we'll get into what those are later, but here, just backing out, okay, just looking at this, you see RT635, JRC, Cali College, there's our 1 ASTM-B, and then there's our penny up there on the top, which might be kind of difficult to see. That's just simple little information that's an actual shot that's been processed, that's been developed, all that good stuff. We see a little bit of undercut there. That's just the actual process. So we set up our shot, we took the shot, ran it through auto, we ran one through auto, okay, which if we were going to run through auto, we'd bring it through the auto and come back in here and check the density. Then, if we were going to do auto, or I should say, or if we weren't going to do auto, we'd go manual, okay, we'd develop, stop, fix, rinse, dry in ours. Then we come out here to develop, or sorry, to check the density and make sure. Once we were sure we've got the correct density, at least a 1.8 for X-ray, bring it over here to the viewer and start looking at it for defects. So kind of an involved process, but when you're actually doing it, it's not near as bad. Any questions? Again, feel free to email me.